Hey guys, we are looking at the second day of these notes for distance formula. We are on page 14 in your workbook, and we're going to go over talking about distance without coordinates. You don't have to have that colossal formula when you just have something like, something like this that's just a straight line. So we're going to look at a number line, and first I want to know the length of segment DJ, which means on the segment I want to know how far is it if I start from D and end at J. I have one coordinate at negative 75 and the other at negative 20. Anytime you're trying to find distance, you do it by subtracting. So I'm going to do negative 75 and I'm going to subtract that negative 20, which is a whole lot of subtraction signs. Your calculator can do this for you, but you could also just say two negatives make a positive. So I have negative 75 plus 20. So I'm going to essentially say that just use calculator, honestly. You subtract them and take the sign of the bigger number. So I'm going to have negative 55 here, which isn't my answer though, because it doesn't make sense to say I am negative 55 feet from you. When you do distance, always make sure your answer is positive. And one of the ways to do that in math is just by taking off the negative with those absolute value bars. So segment DJ is 55 units long. I'm going to do it again, but this time I'm going to do it for length JA over here. So starting at J and ending at A. So one point is at negative 20. The other point is at 60. And like I said, when you find distance, always subtract. Even in your distance formula, you should have had a minus sign in there. You're always subtracting. That's going to give me negative 80 if you use your calculator properly, but I don't want a negative distance. So I'm just going to lop off that negative number. So I get a distance of positive 80 for JA. And I didn't mention it before, but I am writing at the same time as you, so you might be able to keep pace. But if at all you're feeling like, oh no, slow down, Miss Stretch, just pause the video and then pick it back up. Especially for something like this, DA, it would be nice if you tried it yourself, so you could pause it. Or we could just say, okay, I'm going to find this whole distance. One point is at negative 75, the other point's at 60, and like Miss Stretch keeps telling me, what the heck's going on? Like Ms. Rush keeps telling me, I'm going to subtract those numbers. So negative 75 minus 60. That's going to give me negative 135. And then I take off my negative because distance cannot be negative. I get positive 135. And then I want to know, what do we notice about these three numbers that we just got? The 55, the 80, and the 135. You're going to notice that they're on a number line, and if the whole thing is 135 and I took scissors and chopped it right here, we have 55 on the left and 80 on the right. What I'm hoping that you're kind of seeing, at least, if I take that 55 and add on the 80, well, what do you know? It equals the whole thing. It's something that's kind of intuitive. There's an actual theorem called the segment addition postulate, but it basically means if you have two segments next to each other, add them up, you'll be able to find the whole thing. So I didn't have to do this work at all. Instead, I could have just said, oh, I know 55, I know 80, add them up, it has to be 135. Both methods are valid, but they are important things to note that you could do it that way. Then a couple other extensions of this question. Segment DF has a length of 15 units, meaning if I start at D and end at F, I've gone a distance of 15. So that means I could start here at D and go 15 maybe to the left. So let's say this is a 15 here. I want to know where I'd end up. So I'm going to the left, so for sure I'm going to end up as a negative number because it's not a distance, it's a location. Clearly locations can be negative. But I need to figure out what's 15 to the left of 75. Sorry, negative 75. So I'm going to take my starting point and I say I'm going to move left, so minus 15. So I could have a point at negative 90. That could be where F was, at negative 90. But it didn't say it was to the left. It could have been to the right. So I also need to figure out, well, what dot is 15 to the right of negative 75? So I'm going to take my location of negative 75, go to the right a distance of 15, which means I also could have been at negative 60. That could have been where F was. If I don't tell you it's between D and J or something like that, you don't know, it could be either of those locations. Likewise, part F, segment AB and segment AJ, and then it has this symbol, which remember we said yesterday means is congruent. So they're congruent, they're going to be the same, I want to know where B is located. So AJ is already in this picture. Remember, order doesn't matter. If I say AJ, it's the same thing as saying JA, meaning I already know this one's 80. I want to know where could B be located, so it's also going to have a length of 80. So if I start at A, we already have to the left 80. So really the only option would then be to go to the right 80. The question becomes, where is this point that's to the right by a distance of 80? So I'm going to take my location of A, which is at 60. I'm going to go to the right a distance of 80. I'm getting a location of 140. So we don't get a ton of those types of questions, but you will get some like those first three. And you're also going to get a lot like this number 9 here. Suppose that points A, B, and C are collinear. I'm going to stop right there. What I want to point about the word collinear is that right there. It's the word line. And co, like cooperate, means together. So collinear means together on a line. So I just got a line. And I have 3 dots that are together on that line. So I'm going to erase some of this so I can label the picture. I'm going to have to draw through some stuff because I don't have a lot of space. Sorry about that. But I'm going to draw 3 dots on a line, and I'm going to make sure B goes between A and C. So I'm going to draw mine here. So here's my line. I've got 3 dots on that line. They're together on a line. And B is between A and C. It didn't say it's the middle. It didn't say it's the center. It just says somewhere between. So that's what I have labeled. Then it also gives me some length of segments. It says AC is 21, which means starting at A, going all the way to C, that whole length is 21. So I don't know if maybe this side here is 10 and this is 11. I don't know if it's 3 and 18. All I know is that together they make 21. They also tell me BC is 15 minus x, so I'm going to label that 15 minus x. And AB is 4 plus 2x. So like I said, I don't know if I have 10 and 11 or 3 and 18 or 1 and 20. All I know is that it's going to add up to be the whole length. It's going to add up to be the 21. So what we're going to start with for our first statement is just saying what we're pointing out here, that segment AB could be combined with segment BC, and it's going to equal the whole thing. 2 little segments glued together are going to equal the whole thing. I know that they're going to end up being 21. I'm not putting 21 yet, but it will. So my first reason is not given. I did not give you that equation. We had to think about it. And the reason is called segment addition. You are adding segments and getting another segment. Segment addition postulate. But we have the start of an equation now, and we can plug some stuff in so we actually have something to solve. So that's what I'm going to do next. I'm going to say, well, segment AB, we already labeled, is 4 plus 2x. So I'm going to plug in 4 plus 2x for AB. I said that segment BC is 15 minus x. So I'm going to plug 15 minus x in. And I said that AC was 21, and I'm going to plug that in. The mathematical reason for plugging in is the substitution property. We just substituted in what we knew, and now we can ignore the picture. Now we have an equation we can solve, first by combining like terms. I see a 4 and a 15 on their own side to the equal sign. 4 and 15 makes 19. On the same side of the equal sign, I also see 2x and negative x. 2x minus 1x is still a single x. You could write the 1 in front of that, but it's not necessary, and it's probably going to create more work when you do that, so I'm just going to leave it off. The 21's still hanging out over there. So again, all we just did, I'm going to write it down before I forget, is I combined like terms. And then we're almost done, because I want x by itself. That 19 needs to move. The way you would move it is by subtracting 19 from both sides of the equal sign. So I'm going to note that I'm using my subtraction property of equality. Property of equality is the part that we all love to write. So we found x and we justified our work. I did want to go back and also say the lengths of BC and AB. It's when the picture is really helpful. So in the picture, BC, I'm going to write it here because I have space. But in the picture, BC was 15 minus x. I was about to write that, but I know x is 2 now. So I'm just going to do 15 minus 2 instead of 15 minus x. So now I know that BC has a length of 13. I'm going to do the same thing for AB. I could write 4 plus 2x, but I know that x is 2. So I'm getting 4 plus 4, which means I now know that AB has a length of 8. And what I want to point out, if AB has a length of 8 and BC has a length of 13, 8 plus 13 is still 21. Our answer checks out, and we could tell that we did it properly. So we found x, we justified our work, I plugged it back in to find some lengths. We have one more of going through the exact same type of example. So number 10 is very, very similar. Only difference is I actually give you room below it to draw the picture. So given P is between L and A. So I'm going to do that again. I'm going to start by, here's my line segment. P is between L and A, so I'm going to put P somewhere in between. I usually avoid putting it in the middle unless it tells me it's the middle, just so I don't get confused and want to think it's half if I don't know it's half. And then I'm going to label everything that I know, and I'm going to try and color code it to make life maybe easier, make it in case you were confused. So LP is x plus 4. Let's use blue. PA is 2x minus 1. And then we'll use the green. LA, the whole thing, is 5x minus 3. Now these are a bunch of variables, whatever, but it still means the same thing. If I have two little parts, add them up and get the whole thing. So I'm going to start with the first little part. I usually start on the left. That segment is named segment LP. So I'm saying first that I'm going to take segment LP. Please note I called it LP, they called it PL. That doesn't matter. It's still the same beginning and end. Segment LP is going to be combined with another segment, segment PA. So I'm going to add on segment PA. When I do it, I'm going to get the whole big segment. The whole big segment is this guy here. So it's going to have to equal LA. The only reason I'm allowed to do this is not because Mrs. Drush gave me that equation, but because I'm using something called segment addition postulate. I am adding segments together. Two little segments equal one big old segment. And now we can substitute. We're going to plug in, instead of LP, I see my picture has an x plus 4. And hold on a second. There's somebody at the door. I'll finish.